All right, one more topic to cover, and that's dilutions of solutions. Kind of a little weird place to put it, but whatever. So many of our solutions that we get in a laboratory are concentrated, right? So they have very high molarities. The main reason to do this is to save space, right? Water is very dense, very heavy, very expensive to ship from location to location. So if you make a more concentrated solution, you can, have less mass to ship. And then when it gets to the place, you can simply dilute it then, right? So many solutions are concentrated, then diluted when needed. For example, concentrated HCl is approximately 12 molar. So back in the stock room, right, we have 12 molar HCl. And then in lab, all of you all use, different concentrations of the HCl, but that came from that 12 molar stock solution, and then it was diluted, right? So let's take a look at a problem. You have 12 molar HCl. You want 3 liters of 2 molar. So the key to these kinds of problems is that when you're diluting something, you're just adding more volume, you're just adding more solvent. Your moles of solute actually stays the same. So let's go take a look at how we're going to solve this problem. We have 3 liters is our unit that's not a conversion unit. Remember, 12 molar means 12 moles of HCl per 1 liter of solution, and 2 molar means 2 moles of HCl per 1 liter of solution. So those are conversion units. Start with the thing that's not 3.0 liters of our solution. Now, think about what numbers belong to what. We want 3 liters of the 2 molar solution, right? 3 liters of those 2 molar solutions. So those two numbers stick together. So we're going to keep those numbers together. So 2.0 molar, which is 2.0 moles of HCl per 1 liter of solution. And then we want to cancel those out, right? Liters of solution, liters of solution. Now we're at moles of HCl. And what we want to know is how much volume of the 12 molar to take. So then we can use our 12 molar. So 12 moles HCl over 1 liter of solution. And you'll get 0.50 liters of 12 molar solution. So think about what that tells you and what you'd have to do. So what that tells you is that to create the solution that you want to make, you want to take 0.50 liters of 12 molar solution and dilute with water until you have 3.0 liters, right? So the problem solve we did right here was ask ourselves how much of the more concentrated solution do we need to use, and then we dilute it up to 3 milliliters. Now there's actually an easier way to do these dilutions of solution problems, and it all comes from the fact that the moles of your component of interest do not change over time. And so there's a really easy equation. You can look at the book for the derivation of it, but we're just going to go stick straight to the equation. And it's M1V1 equals M2 V2. So M is your concentration, V is your volume, right? And the subscripts talk about which solution you're talking about. So for the one, it's concentration and volume of solution 1. And then the other one, the concentration and volume of solution 2. It doesn't have to be in molar. There's other units of concentration, and you can use any of them, but molar is the most common one. So let's just think about how we would do the same problem that we just did with this new equation. So Again, think about what gets grouped together. The 3 liters is referring to the 2 molar solution, while the 12 molar solution, we have that solution. We just need to know how much of it to use. So we have 12 molar for our one solution. We don't know how much of it to use, but we do know that we want 2 molar at the end, and we want 3 liters of it. We reorganize this equation. The molars cancel out, and we're left with 0.50 liters of our 12 molar solution. So again, different way to do it. The M1V1 equals M2V2 is just a little bit easier, a little bit quicker, and less writing. So let's think about how we're going to create our solution and what exactly we're going to do. So we're going to take half a liter, 0.5 liters of the 12 molar solutions, and then we're going to dilute until we get to 3 liters. So dilute with water until you get to 3.0 liters. Note that I'm wording that a little bit carefully. And so what you might think is, okay, well, I need 3 liters. I have half a liter here, so I'll just add 2.5 liters of water. And then that'll add up to 3 liters, right? Well, actually, not necessarily. When you're mixing liquids, the math doesn't always make sense. So if you have 25 milliliters of one liquid and you add 25 milliliters of another liquid, you will not necessarily get 50 milliliters. You might not actually get that. And if you don't believe me, go ahead, just type into Google or YouTube chemistry, the lost volume. You can do new version. There's plenty of videos that doing the same thing. But basically what they do is they take, in this case, 250 milliliters of water. And then, so let's write this out, 250 milliliters of water, which is H2O. And then they add 250 milliliters of ethanol, which is CH3CH2OH. And when they mix these two, they get less than 500 milliliters of solution, right? So you mix 250 with another 250, but you got less than 500. So what's going on here? Well, if we think about these molecules, H2O is relatively small. So I'm going to draw them as little orange circles. And then ethanol relative to H2O is large, right? It's got way more atoms in it. So I'll draw them as big circles. And so when you mix these two, if you think about how these can interact, right? If we have these big ethanol molecules, we can sneak a water molecule in some of these open spaces where there's no matter there, right? So here we added a molecule of H2O, but we didn't change the mass. Or it didn't change the volume, I bet. We did change the mass. So even though we added more stuff, we didn't occupy more volume because there were some empty spaces here. And so that's why you have to be careful when you're diluting or creating solutions. You generally follow a 2-step procedure. So first you add the more concentrated component. So that would be our half liter of our concentrated HCl in the above example. And then after that, you dilute to the correct volume. In our case, that was up to 3 liters. Now, right, you added half a liter, you'd expect another 2.5 liters that you have to add. But again, you don't measure out 2.5 liters and then mix the solution. No, you add your most concentrated component and then you add however much it takes to reach the correct volume. There are some caveats here for safety. Sometimes the order in which you mix components is important. So there might be some small differences here. But the main point you want to realize is that when you're making solutions, you always dilute to a certain mark. You don't, do simple math of 250 plus 250 is equal to 500, because that's not always true. And again, check out the video. It's like 2 minutes long. It's pretty cool.